Oh, good evening, everyone. I hope you guys are good. All right, right now we'll be doing part 3 of introduction to trigonometry, right, for grade 11 and grade 12. So now we'll be doing our exercises. So we have tan theta. So if we have tan theta is equal to -2/3 and sine theta is greater than 0, calculate using the sketch the value of sine theta times or cos theta times sine theta. Right, first of all, what do? I check. All right, already we've dealt with two types of problem, the Cartesian plane problem and the triangle plane problem. All right, so how do? Usually the vice versa. Usually on the Cartesian plane problem, your angle, your theta is unknown, your value is known. On the triangle plane problem, you have a known angle, you don't know the value here. Usually it will be a variable which is kp. All right, so now by looking at this, I'm dealing with a Cartesian plane problem. Okay, it is a Cartesian plane problem. So we are given a tan of theta is equal to -2/3, right? A tan theta of theta is equal to -2/3. Then we are given a restriction of sine theta is greater than 0. A sine theta is greater than 0. So what do we do from here? What do we do? Right, so we are going to draw a Cartesian plane. Right, so first of all, we draw a Cartesian plane. We have -2 and 3. So what do? I check where in which quadrant is tan negative. Remember, all students take coffee. All right, so all students take coffee. So here it is only sine that is positive, here it is only tan that is positive, here it is only cos that is positive. All of them here in the first quadrant, they are positive. Okay, all of them in the first quadrant, they are positive. So I check in which quadrant is tan negative. So I select 1 and 3. All right, then the second one, it says, remember I gave you two methods, right? So we have an arc if you are given an angle, and when you are given a sine or tan theta is greater than 0, you just use a tick. It is the tick method. We have a tick and an arc, a tick and a tick method. All right, so now we are going to be using a tick and a tick. So where is sine positive? In the second quadrant. So I'm going to draw my diagram in the second quadrant. So first of all, we know that tan theta is equal to -2/3. So what do? I check this. Tan theta is basically a y over an x, right? It is a y over an x. So by the way my diagram is placed or is drawn, I know here, all right, I know only the x value are negative, and here the y value are positive. So I can rearrange this drawing. It can be a 2/-3. All right, because I know my x values here are negative, so it's going to be a -3 and a 2. All right, so what am I left with? Remember the case, we are always supposed to find the value of x, the value of y, the value of r, right? So in this case, we are just left with an r. I'll name this angle a theta, right? I'll name this angle a theta. So what do I do from here? So this becomes, what is my theta? What is my theta? So I have r squared is equal to x squared plus y squared, right? Then what is my x squared is equal to -3 squared plus y squared. What is my y squared is 2 squared. So this will be 9 plus 4, which is 13. Therefore r squared is equal to 13. Therefore r is equal to square root of 13. Okay, so now I can now solve the problem, right? So I have cos theta times sine theta. Cos theta times sine theta. What is cos theta? Remember, cos theta is x over an r. What is sine theta is y over an r. So this becomes, what is my x? Is negative 3 over square root of 13. What is y? Is what did you get for y? It's 2 over square root of 13. So we'll get negative 6 over 13. So that will be our answer for this problem. Right, we go to the next problem. Right, so for this case, they did draw for us. Right, that's interesting. They did draw for us. Okay, they did draw for us. So what do we have here? What do we have here? All right, so let's see. Right, so what do you have here? So we are given x, we are given y, and we are left with r. We don't have r, so in this case r is OP. All right, so the first question says calculate the length of OP. Calculate the length of OP, which is r. So I'm just going to say r squared is equals to x squared plus y squared. All right, so what will I have? So I'll have negative 6 squared plus 8 squared. This will be 36 plus 64, which we get 100. Alright, so r squared is equals to 100. R squared is plus minus 100, which I get a plus minus 10. Alright, therefore, remember r, the radius is always positive. All right, so it's just a 10. Okay, it's just a 10. So we can then conclude our OP is just equals to a 10 units. OP is equals to 10 units. What's the next one? What's the next one? We want what do we want? We want sine theta plus cos theta. So the question wanted us to find sine theta. So sine theta plus cos theta. Alright, so remember sine theta is just a y over an r. What is cos theta? Is an x over an r. Alright, so what are we having here? So what is y? Is 8 over 10 plus negative 6 over a 10. All right, so this becomes a 2 over a 10. We get 1 over a 5. All right, so that's the answer for this one. Are we good? So that's the solution for this one. All right, now look at this. These are the all right. Okay, oh yeah, look at this. So this one, the second one, it is a, what do you call this one? It is a triangle problem. All right, how do you solve it? How do you see what is a triangle problem? I think I'll need space here. All right, let's see. Let me just use this section. Yes, let's see. Yes, so the answer is 1 over 5. All right, it's 1 over 5, so I can just erase this one. Let me just erase this part. Right, so I hope you understood this section. You can even pause the video to understand it. So that was sine theta plus cos theta. Right, so now what do you want? We want we're given sine 25 is equals to 1 over k. All right, equals to 1 over k. Remember, always remember this. Right, once you have an angle and once you have a variable here, right, as your equal, after your equal sign, we are dealing with a triangle method problem. All right, triangle plane methods. All right, so what do we do here? Remember, every time we draw a Cartesian plane. All right, so right, this one is 25. So if I'm having 25 here, I'll be having 65 here. 65, right? I'll be having 65. Then remember, we are always drawing a triangle problem, which is 90. So then what do? I'm here at 25. I'm here at 25, right? So remember, sine is always what? It is an opposite over hypotenuse. Alright, it is an opposite over hypotenuse, which means my opposite will be 1. My hypotenuse will be k. Alright, so remember, what did we say? Always this side is represented as y, this one is represented as an x. So what am I left with? I need to find x. So I'm going to say r squared is equal to x squared plus y squared. Right, so this will be k squared is equals to x squared plus 1 squared, which is k squared is equals to x squared plus 1. K squared minus 1 is equals to x squared. Therefore, x squared is equals to x squared is just plus minus k squared minus 1. All right, then x squared is equals to a plus. Remember, in this case, in the triangle plane method, our x value and the y value are always positive. All right, they are always positive. So what do we do here? Already I have the x, so I can just replace it here. I have the x, so I'll just replace it here. So I have k squared minus 1. All right, so what is the question? Remember, the question, it wants us to find tan 25. So I'm going to say tan 25 is just an opposite over an adjacent. All right, so what is my opposite for this case? So it's just a 1. So if I'm standing at 25, my adjacent will just be a square root of k squared minus 1. Then what do we have? You rationalize it, so times k squared minus 1 over k squared minus 1 times k squared minus 1. So this becomes k squared minus 1 over k squared minus 1. So this becomes a solution. Okay, this becomes a solution. Okay, so now we go to the next question. All right, seems interesting. Right, already this one we are dealing with the Cartesian plane. Right, so what are they saying here in the diagram below? P, where is P? Or P, we are given x and negative 25 is a point such that OP is 25. All right, so such that OP is 25. What is OP? OP, it is basically a radius. All right, OP, it is basically a radius. Right, then they gave us a point which is R. What did I say? R with ROP. Oh, okay. Right, I see that one. Then what is the first question? Right, remember the question. It says always make sure that you find the x value. Although they didn't ask you, but make sure that you find the x value, your y value, and your r. Right, so in this case, what is the missing term? It is basically r. It is r. So I'm just going to say r squared, it is x. R squared is equal to x squared plus y squared. So what is my r? R, they said is 25, so it's 25 squared is equals to, what is x is unknown. What is 24, which is 24 squared. Right, so what do we have? This is 625 is equals to x squared plus, right, let's try this one with the calculator. A square root of a square of a 24, let's see, 24 squared, we get 576. Yes, so then we solve for x, which is 625 minus 576 is equals to x squared. X squared is equals to, what is it, minus 625, listen. So we are getting x squared is equals to 49. All right, Then remember we said x squared is equals to plus minus 49, so I'm going to get plus minus 7. All right, so I'm getting two possible answers. The first one is positive, the second one is negative. All right, then I have to select here. Remember, in this one we said we need to always have two answers. X can be positive or x can be negative in the Cartesian plane problem. Right, so I check in which quadrant am I in, which is the third quadrant. So I'm expecting the negative x values here. So my x is going to be negative 7, right? Negative 7. So I have my x value. Then the first question it says that find sine b, right? Find sine b. I know sine in the Cartesian plane problem is always y over an r. What is y? Y we got 24. What is r is 25. That's the solution. What is b? Cos of 180 minus b. This is the same as right, this one is in the third quadrant, second quadrant, and cos is negative, so it's negative cos b, right? So what is cos b is negative. What is cos b? Cos b is just an x over ar, so it's negative. What is my x? Negative 7 over r, so this becomes 7 over what? Is 7 over 25. So it's a 7 over a 25. Okay, 7 over a 25. Right, then we come to the third question. It says c. What is it saying here? C is equals to a tan of squared negative b. All right, so how do we solve this one? Usually allowed to say tan negative b. I put it outside the bracket, which means I'm having two tan negative b, two of them, so I just write it in this format. All right, then I say what is a tan of a negative b? So a tan of a negative d is in the fourth quadrant, is just a negative tan b squared. All right, then what do I do from there? What do I do? We know tan is just a y over an r, so it's negative y over an r, or over an x squared. So what will we have is negative, what is y? Is negative 24 over x, which is negative 7 squared. So what will I have? I will have negative 24 over 7 squared. So when you punch it on your calculator, that you'll be having a 24 over 7 squared. So it's just a 5 is a 576 over 49. 576 over a 49. Okay, 576 over a 49. Right, so then what does it say? It is a point such that OT is 15. All right, this one is, let's see, it is a point on OP. Right, so how do you do this one? Okay, I'm just going to write a point here. I'll assume I have a point here. I call it T. All right, I have a point here. I call it T. Do I know the x value? All right, do I know the y value? No. So how do you determine? All right, okay, I already see the solution. Right, let's see an attempt. How can you attempt this one? All right, remember this was the last answer, né? This was the last answer. Okay, so how can you attempt it? Right, here's a method. I'm thinking of something. right? Yes, all right, I have a solution. Let's see this. Let's cancel here. Let's cancel here due to space, because underneath I have another problem. All right, okay, let's just cancel here. I hope everyone understood here. Let's just cancel here. Let's cancel here. Let's see. It's really interesting. It is really interesting. It is a really interesting question. It is a really interesting question. Okay, so what can we do here? One thing I know, right? Let's see. All right, so one thing I know here. What am I doing? All right, yes, let's start writing. All right, so one thing I know here, we know these 2 points, this one and P, they're sharing an angle, right, which is theta, which is beta, right? They are sharing an angle, right? So I can just say the first one, sine of beta is equals to using point P for point P. All right, for point P is equals to a y over an r. All right, so what did you get? Sine beta, I think we have already solved it, just that I can't recall it, but it's negative 24 over r over 25. Okay, then according to point T, sine beta is going to be a y over an r, but we don't know the y, we only know the r. They gave us the r, so I'm just going to say it's y over r, which is 15. Okay, so do you see I'm having a sine beta, and a sine beta. These 2 sine betas, they're giving me 2 different things. Therefore I can just say sine beta P is equal to sine, because every time I'll get the same solution though, right? If we knew the angle, they're sharing the same angle. All right, sine beta T, right? So I know sine beta T is equal to 24 over 25 is equal to y over 15. Therefore y is equal to negative 24 over 25 times 15. So what am I having? So it's negative 24 over 25 times 15. Right, so I'm getting negative, it's a negative 72 over 5. Right, already we got this one. All right, then we come to cos now. Cos beta P, right, is what? Is an x over an r. What is an x here? I think we got negative 7 over what? Over 25. All right, then we say cos beta what? T. Right, let's see. Cos beta, let's see. Right, okay, it's going to be an r x over an r. Right, so what is my x for this one is unknown. My r is 15, so it's just going to be negative 7 over 25 is equals to x over 15. All right, so it's going to be negative 7 times 15 over 25 is equals to an x. What are we getting? Let's see. Negative 7 times 15 over 25. So I'm getting a negative 21 over 5. Right? Therefore, it automatically makes T equals to negative 21 over 5 And what is my y? Or negative 72 over 5. Okay, over 5. Right, let's go to the next one. Determine the area of R. Where is it? R. Is it R-O-T? R-O-T. Okay. Is it necessary to do this one? Listen. Let's just skip it. We'll come back to it later. Right. Now let's come to this one. What am I having here? Why is this? There is a u here. All right, let's say we are given cos of 23. All right, cos of a 23 is cos to square root of 1 minus g squared. Right, so what do? First of all, we check what type of problem are we dealing with here. We deal with a triangle problem, right? What do? Remember, triangle problem is an angle that is known and the variables here are unknown, right? The variables there are unknown. So what do we do? Okay, every time what we do, just break it down here. This will be over a 1, and I know a cos is just an adjacent over a hypotenuse. Right, so this is what I'm having. This is what I'm having. Right, so what do we do from there? What do we do from there? So I'm having a 23 here, a 23 here. If I'm having a 23 here, what will I have here? I think it will be, is it a 70? No, it's a 67. 90 minus 23 is how much? 90 minus 23, oh, is a 67, yes. So I'll be having a 67 here. Right, and here it will be just a 90. Okay, so what do we do here? So first of all, I know I'm having opposite. If I'm standing here, my adjacent will be square root of 1 minus g squared. My opposite will be, what will be my opposite? Oh, it's just unknown. My hypotenuse is just a 1. Right, so I'm left with a y here, so it's just an x squared plus y squared is equals to r squared. So what is my x? Is 1 minus y squared plus y squared is equals to, oh, g is g here, my mistake. Let me erase because something is a mess now. All right, so we are saying it is a what? Square root of 1 minus g squared plus y squared is equals to a 1 squared. Therefore is 1 minus g squared is equals to y. Oh, it's plus y is equals to 1. All right, then I transpose everything to the other side, so I'll have y is equals to 1 minus 1 plus g squared. Right, so y squared is equals to a g squared. We put a square root, we get two possible answers. Right, so it's going to be plus minus a g. Then I have to select. Remember, in the drawing we are always taking a positive answer, so it's going to be a g. So y is equals to a g. So this one I can just replace it with a g. Then the first question is says sine 23 is equals to, what is sine 33? Opposite over hypotenuse. What is my opposite here? Is g. What is my hypotenuse? It's a 1, so it's just a g. What is a tan of 103? right? So it's just a tan of 180 minus 67, right? So this is negative tan of 67. What we do, tan is just what is tan? Is an opposite over adjacent. So I'm standing here. What is my opposite? So it's just a square root of 1 minus g squared. What is my adjacent? Is just a g, right? I hope everyone understand. Then the last one, oh, this one is tricky, but not that bad, not that bad. Let's see. So we are having a sine of negative 653, right? So when you're having a negative angle, just add a 360. So it's sine of negative 653 plus a 360. What am I having? I'm going to have a sine of let's see, negative 365 negative 653 plus 360 is negative 293. Again, plus a 360 is sine of negative 293 plus a 360. So plus a 360, what are we getting? Also, it's going to be a sine of 67. All right, so what is the sine of 67? So I'm standing here, so it's just going to be opposite. This will be my opposite, so it's going to be opposite over hypotenuse. So my opposite will be square root of 1 minus g squared over 1. So it's just the square root of 1 minus g squared, right? That is my solution. Next question, let's see. What are we dealing with here? Okay, we are dealing with a Cartesian plane problem, right? It is a Cartesian plane problem. So what do we do in the Cartesian plane problem? What do we do? Cartesian plane problem. Let's see. We are given a cos of 1 over 3. So I just draw a Cartesian plane. I say we want where cos is negative, right? So it's the cos of theta is equal to negative 1 over 3. It's a tick and an arc problem. Why am I saying it's an arc? Here, an arc problem, we will always be given an angles between, right? So we want where cos is negative, so it's negative here and here. Then we want an arc between 0 degrees and 180. So I'll just 0 degrees and 180. Do you see? So then we select a point where there is an arc and a tick. So basically it will be in the third quadrant. The third quadrant. And what do I have? I know cos is just an x over an r. So I know here I'm having a negative 1. I don't know why, and my r is just a 3, right? So what do? I'm left with a y. So we're going to say x squared plus y squared is equal to r squared. So which is negative 1 squared plus y squared is equal to 3 squared, which is 1 plus y squared is equal to a 9. Y squared is equal to a 9. It's equal to a 9 minus 1. Y squared is equal to an 8. Y squared is equal to plus minus 8 square root of an 8, which is plus minus 2 root 2, right? So we select a one answer here. So we check in the second quadrant, our y is what? It is positive, right? So I'm expecting a positive answer, so it's plus 2 square root of 2. So that is my solution. All right, so that is my solution. Okay, then what do we do from there? What do we do from them? Okay, now we want, they want us to find tan 180 plus theta. Well, this one is simple. So tan 180 plus a theta. We know this one is in the third quadrant. 180 plus a theta is in the third quadrant, and tan is positive. It's just a tan of theta. And we know tan theta is just a y over an x. So I know I'm going to have 2 root 2 over, what is my x, is -1. Alright, it's going to be -1. Okay, so my solution is just going to be let's see, it's going to be -2 root 2. So that's the solution that I got. That's the solution that I got for this one. All right, let's go to another question. Okay, this one will be our last question. This one is cut, so is tan 438. I hope I wrote the right thing. Yes, 438. I hope that's the one. Okay, so we are quite fortunate to have 2 problems in one case. You are always going to find them in one case. So how do you see? Remember, I've shown you a method on part 1 and part 2. All right, how do we see the difference? This one, it is a triangle plane method. Why? Because I'm having my angle as known, I'm having my equal sign as a variable that is unknown. When it is a Cartesian plane problem, my angle will be unknown and my value will be known. I hope that makes sense. Right, so let's start with the first one. They say we are given a 12 tan b tan minus 5 is equals to a 0. All right, so first of all, simplify this. So we are going to say tan beta is equals to a 5, 12. Therefore, tan beta is equals to a 5 over a 12. Right, so I already see my solution is positive. I draw a Cartesian plane. I want where tan is positive. It's in the first quadrant and the second quadrant, right? Then they give me a restriction between 90 and 360. Remember, so this one is a tick and an arc. So from 90 to 360. Do you see? So the arc touches the tick at what? At third quadrant. So I draw in the third quadrant. All right. So check. Remember, tan is equals to a y over an x. But what am I having here? Do you see that what I'm having here? I'm having 2 possible answers, 2 positive answers, right? And here in the third quadrant, my answers are negative. I know my y values here are negative. I know my x values here are negative. So what happened here? So it initially means it was -5 over -12, right? So that it can accommodate this. So it's -12 and -5. So I'm having my x value, I'm having my y value, which means I'm left with the what? An r. So you calculate the r. R squared is equal to an x squared plus y squared. So r squared is equal to -12 squared plus -5 squared. This will be 144. This will be 25. So this one is 169. So what do we do here? So r squared is equal to 169. Put a square root, I get 2 possible answers, which is a 13, right? But in r, we always say r is positive, so it's plus 13. Right, then we answer their problem. They say 1 sine beta plus cos beta. So I know I'm dealing with a y over an r plus an x over an r. So this one, what is my y? Is -5 over 13 plus -12 over 13. What am I getting? Is -17 over 13. So that will be the solution. That is the solution for this case. Okay, all right. So that will be the solution. Go through it. Now let's shift to the Cartesian plane problem. We're doing the Cartesian plane problem. Now we have to shift to the triangle plane problem. All right, Guys, these are good 10 marks. Good 10 marks that you should attain every time. It's a good 10 marks for free, right? A 10 marks contributes to, what is a 10 of 150? Let's say of 360. If you have written 2 papers times 100. What is a 10? A 10 of 360 times 100. Oh yeah, a 10 of a 360 is just a 3%, so that will be a 3% of your total report. You need that 3%. You need that 3%. So which means for your paper 1, for you to get this, it represents your 7%. For your paper 2, excuse me. Yes, for your paper 2. So now let's try to attain the triangle plane problem. Triangle plane problem. What do we do here? What do we do? The triangle plane problem. Okay, let's attempt it. Right, so we are given this one is the easiest. So we have given sine of 43 is equals to a p. I know sine is just an opposite over hypotenuse, right? So which means there is a 1 here. So what do I do here? I draw a triangle, a right angle. I draw my angle here. So I'm having 43 here, which means here I should be having a 47. All right, 47. So if I'm standing here, what is my opposite? It is a p. What is my hypotenuse? It is a 1, which means we are left with an x. So we are going to say y squared plus x squared is equals to r squared. So this will be p squared plus x squared is equals to 1 squared, which is x squared is equals to 1 minus p squared. X squared is equals to plus minus square root of 1 minus p squared. Remember, we're always selecting the positive answer for a triangle plane method. So it's just 1 minus p squared, right? So then we can solve our problem. They want a cos of 133. A cos of 133 is the same as a cos of 180 minus 47. So what do I do? This is a negative cos 47. I know a cos 47 is just an adjacent over hypotenuse. Okay, so what is my adjacent of 47? My adjacent for 47 is just a p over, what is my hypotenuse over 1? So it's just, I'm having a negative p. That will be my solution. All right, that will be my solution. Okay, then we have a tan of is it a 438? Yes, 438, right? So if you're having a number greater than 360, you just subtract. So a tan of 438 minus 360. Let's see, what are we having? 438 minus 360. We're having a 78. I'm not sure. Listen, I think I wrote something wrong here. Let's see. A 78. 912. I think there's something wrong here. Let's say if it was a 2. There's something wrong here. Just that I can't recall what we had here. Let's see. Let me see something. Okay, let me see something. Oh yeah, I'm not thinking. Oh wait, but okay, it's fine because I can't find 78 here. so which means I copied this incorrect, right? So but for now, let's just make it 103. Let's just make it 103. All right, so if we are given a tan of 403, so we are going to have, let's see, we're going to have 8 minus 360. Yes, so 180, so minus 360, I'll get a tan of a 43, right? What is the tan of a 43? Is just an opposite over an adjacent, so it's just going to be a p over square root of 1 minus p squared, right? When you rationalize it, it's going to be p 1 minus p squared over 1 minus p squared, right? That's what we have. That's what we are having. So what was this one? 438. I wonder, let's say 438, let me see, 438 minus 360. Okay, then, but it doesn't make sense. It doesn't make sense at all. It doesn't make sense. Right, but let's proceed. Oh, this one is the last question. Oh, it is not. So I'll just do this one, then the rest will be on you. All right, the rest will be on you. Let's try this one. 6 marks, guys. It's just free 3 marks. It's just free 6 marks, right? So let's say we are having this is a Cartesian plane problem. We have a restriction here. This is a tick method, right? This is a triangle plane problem. Okay, let's have this one. So we have tan theta is equals to 3 over 7, right? I draw my Cartesian plane. I want where tan is positive, so it's positive in the first quadrant and negative in the positive in the third quadrant. Ne? Then I want where cos is negative. It's negative here and also here. You see, already is telling you where I should draw my Cartesian plane. So this I will have, and again I'm having a 3 and a 7, and I'm in the third quadrant. I know my y value and x value is negative, so I'll assume this was negative 3 over negative 7. So I'll have negative 3, negative, remember, is negative, it is a y over an x. Yes, it is a y over an x. So my x is negative 7, my y is negative 3. Okay, so what do I do now? I'm just left with an r for this case. So r squared is equals to x squared plus y squared. So this will be r squared is equals to a negative 7 squared plus a negative 3 squared. So this will be a 49 plus a 9, which is a 58. So r squared is just the square root of 58. All right, what is the square root of 58? Square root of 58 using a calculator, it's just the square root of 58, right? Then how do we do this one? We are given a sine theta plus cos theta over 2 sine theta. All right, then what do we do here? It's just this will be a y over an r plus an x over an r over 2 times, what is a sine y over an r? So this will be, what is my y? We have negative 3 over square root of 58 plus, what is my x? Is negative 7 over square root of 58. What is my y? Is negative 3 over square root of 58. Right, let's just simplify it. This one here will have negative 10 over square root of 58 over negative 3 over square root of 58. Then when you just put it on your calculator, although they didn't say, remember I always say you cheat in a smart way. So this one will just be a 10 over 3. Yes, it's just a 10 over a 3. a 10 over a 3. All right, so try this one. Try this one and also this one. Very simple, hey? Very simple. All right, so we will call it a day. We'll call it a day. Call it a day. Right, have an amazing evening. Bye.